Bitcoin's Lightning Network upgrade. Possibly the most pivotal moment in Bitcoin's history, as it attempts to implement an upgrade that will allow global scalability with virtually instantaneous transactions at very low transaction fees. Before we get into that, let's provide a bit of context by looking at Bitcoin's scaling history. See, during the past 6 months, Bitcoin has become more and more popular as people both buy it and use it as an alternative to traditional fiat currency. The problem with this increased adoption and usage is the Bitcoin network has become congested, drastically slowing down transaction and making transaction fees more and more expensive. As we can see here, Bitcoin's average transaction fees got to a high of $55 per transaction during late December 2017, before starting to reduce leading into February of 2018. This price increase coincided with an increase in the volume of transactions as more and more people were buying Bitcoin during this period. This can actually be also correlated with an increase in Bitcoin's active wallet addresses during this time. We also saw Bitcoin's block size filling up close to 1 megabyte, but we'll come back to that in a bit. You see, the other major problem in addition to Bitcoin's high transaction fees during this period were the slow transaction times. During the month of December 2017, there was a median transaction confirmation time of around 1.7 hours and an average confirmation time of around 4.7 hours. During January, however, the median time was around 3 hours with an average time of 16.5 hours for a single transaction. Based on the past few months, Bitcoin has become more expensive to use, and with transaction times also increasing, its utility as an alternative form of currency has drastically dropped. So why has this happened? Let me explain. See, the way Bitcoin works is the sender of Bitcoin gets to choose how high they want to set the transaction fee, so long as they're using a wallet that allows this, where the higher the fee, the higher in the priority list the transaction gets, essentially meaning it has a higher chance of getting confirmed faster. The actual price of the fees themselves are based on supply and demand, which is built into Bitcoin's protocol design of a free market for block space. This is where things get a little complicated. See, Bitcoin has a maximum block size of 1 megabyte, with transactions being the data that fills these blocks until it's confirmed by a miner. As we can see on this chart, which is the block size over time, we can actually see as Bitcoin has grown in popularity over the years, the blocks have started to become more and more filled with data. Around mid-2017 is when blocks started to become full to capacity. Bitcoin is also designed to have miners confirm 1 block every 10 minutes. But as you can see here, this can actually vary a few minutes either side depending on transaction traffic. So essentially, Bitcoin's architecture design has 2 major constraints on it. One being the maximum block size of 1 megabyte and the other being the block confirmation time of around 10 minutes. So when transactions increase at a rate beyond Bitcoin's constraints, the remaining transactions go into a large list called the Bitcoin mempool. This is when Bitcoin becomes too slow and too expensive to use, and its utility drops as a real-world alternative to traditional currency. So this leaves Bitcoin with a major issue. If this immutable and decentralized currency is ever going to be used by millions of people around the world one day, well, how's that going to happen with high transaction fees and slow transaction times? Well, there was 2 options. One was to increase the block size to allow more transactions to be captured and thus confirmed, and the other was to decrease the confirmation time from 10 minutes down to a lower number. This would essentially allow more blocks to be confirmed in a shorter time. This issue has been raised and discussed as early as 2013, with old Bitcoin talk forums containing discussions between forum members and former Bitcoin core developers such as Gavin Andreessen and Peter Todd on increasing the block size limit. These early discussions indicated that there was some disagreement between developers on how to scale Bitcoin, with arguments against raising the block size limit being greater infrastructure would be required in several years, such as internet connections and hard drive space, because Bitcoin's blockchain size would exponentially increase, potentially leading to centralization of mining pools. So fast forward a couple of years to July 2015, which was when Bitcoin Improvement Proposal 101 was submitted by Gavin Andreessen and proposed to increase the block size limit. The proposal was to increase the block size limit to a size that would grow over time at a predictable rate. The proposal was to increase the block size limit to 8 megabytes in January 2016 and to double the block size approximately every 2 years, with the block size capping at 8.2 gigabytes in the year 2036. Objections to this proposal included the centralization of full nodes and mining, as the internet bandwidth and disk space requirements would significantly increase over time due to the requirement of more expensive hardware and internet speeds. Other objections included the centralization of mining in the form of big block attacks, where simulations indicated that larger blocks increased the advantage of miners with high bandwidth connections. According to GitHub, Bitcoin Improvement Proposal 101 was withdrawn. There followed a number of Bitcoin improvement proposals relating to increasing the block size limit, all of which were either kept in draft or were rejected. The second major constraint, which was the 10-minute block confirmation time, never really got major support, as it was seen as integral to not only keep security on the Bitcoin network, but to also keep it as decentralized as possible. Now, this brings us to the activation of Segregated Witness, which was finalized in Bitcoin Improvement Proposal 148 in early 2017. Segregated Witness, or more commonly termed SegWit, was proposed as a soft fork, essentially meaning an upgrade could take place without Bitcoin's protocol having to require a split. And this SegWit upgrade was to include a number of features to Bitcoin under something called malleability fixes. These fixes would allow a number of upgrades to Bitcoin, but most importantly would facilitate the implementation of the Lightning Network. So what is the Lightning Network? Well, the Lightning Network acts as a second layer by bringing in something called payment channels. And these payment channels essentially allow transactions to occur off-chain without every transaction having to be broadcast to the Bitcoin network. So what does this actually mean? Well, what it means is that the Bitcoin network will be capable of performing essentially instantaneous transactions without transactions having to wait for a block confirmation. It also means that micropayments will be possible, allowing very, very small sums of Bitcoin to be transferred at virtually zero cost. And lastly, the Lightning Network will allow Bitcoin to mass scale to virtually an unlimited size in the years to come. So why is this such a big deal? Well, the Lightning Network upgrade has been compared to how the internet had to scale. See, when a transaction occurs on the Bitcoin network, no matter how big or small, it is broadcast to all connected nodes on the network. And this is analogous to how the internet used to function, where Ethernet hubs had to transfer data between computers. The data would be broadcast and replicated out through all other interfaces or ports on the network. This greatly limited the internet from mass scaling, as it became virtually infeasible for data to be transmitted or broadcast to every participant on the network. Network engineers overcame this issue by developing something called unicast, where data was able to be routed from its source to its destination without having to be replicated to every network participant. The Lightning Network and its payment channels is being compared to the internet's unicast, where nodes will be able to route point-to-point transactions without having to replicate the transaction on every node on the network. So essentially, the Lightning Network is being compared to the internet's TCP/IP, eventually allowing global scalability. So the Lightning Network sounds like the ultimate solution to Bitcoin's scaling issue. However, there have been major objections. Bitcoin Cash was created in August 2017 by forking the Bitcoin blockchain after it was announced by Bitmain as a contingency against BIP 148. Bitcoin Cash chose to fork Bitcoin's blockchain, essentially creating a copy of Bitcoin's protocol. The difference was there was change parameters, such as an adjustable block size limit with the minimum being raised to 8 megabytes. So in a nutshell, Bitcoin Cash decided to keep all future transactions on the ledger without adopting any second layer off-chain scaling. The creation of Bitcoin Cash and Bitcoin coexisting has created a deep divide between developers, users, and the community. Conspiracies run deep on both sides as to intentions, agendas, and how Bitcoin should be handled and scaled. The fact that Bitcoin is so open source and decentralized is largely the reason for this, but this is also the reason that Bitcoin is so strong and so resilient. Alright, so with that out of the way, what about the Lightning Network's development? Where is it up to right now? Well, in early December 2017, the Lightning Network mainnet testing began after a successful trial on the testnet. Developers and enthusiasts alike could start testing the Lightning Network themselves. Just a few months since the mainnet has been open for testing, the number of nodes running the Lightning Network has started to drastically increase. The live Lightning Network mainnet shows as of today, the number of nodes is now at 630, with 1,796 payment channels in operation. The largest cryptocurrency exchange in the world, which is Coinbase, is now integrating SegWit. meaning that once completed, the Lightning Network will be able to be implemented, although this is likely still some time away. With the number of nodes running the Lightning Network increasing every day and general sentiment becoming more and more optimistic, it's just a matter of time before the Lightning Network starts being implemented all around the world. Bitcoin's purpose, which is to be an alternative medium of exchange and store of value, will return, and it will provide amazing utility to its users. The Lightning Network will allow very fast transactions at very low fees, while simultaneously being ready for global adoption. One thing's for sure is I am very optimistic and excited for Bitcoin's future. So that's it for this video. Thanks so much for watching, and I hope you enjoyed. If you did, likes are always really appreciated, and if you haven't subscribed, consider doing so if you want to see future content. My name's Bo, thanks again for watching, and I'll see you guys in the next one. Cheers.